Okay, welcome to another round of probability questions. Let's get straight into it. Sammy asked 50 people which drinks they liked from tea, coffee, and milk. All 50 people like at least one of the three drinks, so they are all in the set. So, when presented with a huge data set like this with distinct different options, and certain people and certain numbers of people who like certain things, this to me immediately says Venn diagram. So if you were thinking something else, it can be done without. It's much easier to draw. So let's go over the side and draw a nice Venn diagram. With these kinds of questions, like I've said previously, a Venn diagram is crucial. A correct Venn diagram is crucial to getting full marks. So T, C, coffee, and milk, M. So all 50 people like at least one or three drinks. So we know that all 50 are going to be inside these three circles. 19 people like all three drinks. So where would you start putting this 19? Because I would put it right there. It's the first piece of information they give you. It should be the first one you deal with. However, with these kinds of questions with a Venn diagram involved, it's always best and also works the best if you start in the middle, because then you can start to work outwards. And you'll see what I mean later. So if we start going through to the next statement, 16 people like tea and coffee. So T and C, but not milk. So there are 16 people who like tea and coffee, but not milk in 16. Because if we put them in here, that assumes that says that they like milk. But here's the tea and coffee only section. 21 people like coffee and milk. So they don't distinguish only coffee and milk and not tea. So we have to count this 19. So we have 21, 19. So 21 plus 2, 19 plus 2 equals 21. So here in the total, in this little intersection between coffee and milk, see if I can make this a little clearer for you. Coffee and milk, like that. We have 21, which satisfies what they've given us. 24 people like tea and milk, so we do the same thing. 24. This time it's going to be 5. 19 plus 5 is 24, right? Yep. And we're going to make this a little clearer. We have there's tea and there's milk, and giving us 24 precisely. 40 people like coffee. So this is where the working outwards things become really clear. 40 people like coffee. So in all this whole big circle here, let's actually go in a different color here to make this a little clearer. In all of this big circle here, 40 people like coffee. So what we should do here is not put 40 just like that and leave it, because that's wrong. Because then you have 40 plus 16 plus 19 plus 2 who like coffee, but we're told that only 40 people like coffee. So we need to do 40 minus 16 plus 19 plus 2, which gives us, let me get my pen out, which gives us 3. So now what happens is if we add 3 plus 2 plus 16 plus 19, that satisfies the 40 people in the coffee circle. And one person likes only milk. One person liking only milk. This is the only little section that says only milk. And we're told that Sammy selects at random one of these 50 people. So to complete this last little empty section, what we can do is just do 50 minus whatever we've got here. So 50 minus, we go 16 plus 3 plus 5 plus 19 plus 2 plus 1, and we get 4. So now all 50 people are represented in some way on this Venn diagram. Okay, now let's actually deal with the question. Now that we can actually do it. Sammy selects at random one of the 50 people. Work out the probability that this person likes tea. So out of 50, these are all the people who like tea. Let me see if I can get a different color out here. Let's go with a nice little pink. All of this is the T circle. So out of 50, oops, can I get my normal pen, please? Thank you. So out of 50, like that. Out of 50, we've gone 4 plus 16 plus 19 plus 5. And that gives us 44. Let's go back to that. 44 out of 50. And we can just leave that like that. It can be cancelled, but I don't think Mark seems specify whether you need to cancel or not. They accept these kind of answers. Best not to waste time. Given that the person selected at random from the 50 people likes tea, find the probability that this person also likes exactly one other drink. Okay, so I'm going to leave this open. What would you do here? Would you go out of 50, like we've just done, or would you go out of 44? And if you chose out of 44, well, you're correct. And the reason for that is, given that the person selected likes tea, so we're told that we're going from the people who like tea. So given that they like tea, when they say this, this is what they mean. They mean from the people who like tea. So out of the 44 people who like tea, finding the probability that this person also likes exactly one other drink. So if we look at the people who like tea, we have these 4 people who only like tea, so that's not one other drink. We have these 19 people who like exactly 2 other drinks, coffee and milk. But we have this 5 and this 16, and these 5 like tea and milk, so exactly one other drink being milk, and these 16 like tea and coffee, with the one other drink being coffee. So we do 5 plus 16, give us 21 over 44, out of the 44 people who like tea. And that's our answer. Okay, here's another little Venn diagram question. This one's a little different because they have things outside the set, I think, at a glance. So give this one a go, and I'll start going through it now. So we're told to complete the Venn diagram to represent this information. So first thing we do obviously is label the circles, A and B. The first set of numbers is comprised of 3, 9, 15, 21, and 27. The second one is 5, 15, and 25. And the entire sample space is odd numbers less than 30. And you can see that not all of them are represented here. So there will be stuff outside, but we'll come to that later. So there's only one number overlapping, 15. So what you won't do is put 15 here and 15 here, because representing on a Venn diagram, the 15 is common to both. So the 15 goes in the space dedicated to numbers that are common to both. Next, we're going to start with B, 5 and 25. A has 3, 9, 21, and 27. However, we're told that the whole set is odd numbers less than 30. So if you'd have moved on at this point, you would have lost a fair few marks. So what we have to do here is look at the list, which is 1, 3, 5, so on, and look at what is not in A and B, and therefore should go outside. So 1 I can already see goes outside, 3, 5, 7, 9, 11. Just doing this just to make sure there are no mistakes. Under exam pressure, you may think, you've got it under control, but exams are strange things. So let's go through this. 1, 3, there is. 5, there is. 7, there is. There isn't. Don't do what I did. Do as I say, not as I do. This is a 27, not a 2 and a 7. 7, there isn't. So let's put a 7 over here. Nice and spread out so we don't make that mistake again. 9, there is. 11, there isn't. Put 11, 13, there isn't. 15, there is. 17, there isn't. 19, there isn't. I'm running out of space there actually. 21, there is. 23, there isn't. 25, there is. 27, there is. 29, there is not. And that's how you get your whole 4 marks. That's the complete set, because this satisfies everything we've told you. In the sample space, there are all the odd numbers less than 30. In A, there are these numbers, 3, 9, 15, 21, 27. And in B, there are those numbers, 5, 15, and 25. A number of shows in at random from the universal set. That is what it's called, a sample space universal set. I believe it is called a sample space. And I'll check that. What is the probability that the number is in the set A union B? And it is called a sample space is a set of all possible outcomes in an experiment. So, like a tree diagram or a table or a list. But I think this in some way does represent all the possible outcomes. So, moving on. What is the probability that the number is in set A union B? So, everything that is in A and everything which is in B. So we have 3, 9, 21, 27, 15. So 1, 2, 3, 4, 5, 6, 7 numbers out of the odd numbers less than 30, which are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15. 7 out of 15. That's your answer. You just look at A union B. And you have to remember this notation because it is very crucial. And we can jump straight into this one. The probability that a new fridge has a fault is 0.015. What is the probability that a fridge does not have a fault? So another way of writing this is a complement of fault or not fault, which would be 1 minus 0.015, which gives us 0.985. So it's just the inverse, because there must be a fridge, fault or not, and we're not given any sort of in between or neither outcomes. So we know that the fault and the non-fault or the functional must add up to 1, which is why we do this. Next up, question 5. There are some boys and girls in a classroom. The probability of picking at random a boy is 1/3. The probability of picking at random a boy is 1/3. What is the probability of picking a girl? That is simply not a boy. In this situation, just boys and girls. Not a boy. 1 minus 1/3 equals 2/3. Same principle as the one above.